Hello IXI, my name is Gabriel and today I'll talk about my work on containing malicious package updates with a lightweight permission system. But what are malicious package update attacks after all? Well, in this type of attacks, attackers usually target an application or users of an application, but attack a package dependency instead, which is sufficient for attackers to perform malicious actions such as stealing credentials or bitcoins. Some assumptions about these attacks is that we do not expect authors to turn against packages, but it is more common that attackers use leaked credentials or target weak passwords to obtain access to accounts. Also, targeted packages are usually not core to the application and can be as trivial as the leftpad package with only 10 lines of code. Now let me give you one of the many examples of attacks that have been observed in the wild. On July of 2018, a package dependency named ESLintScope was the target of a malicious package update attack. This package is part of the ESLint application, a tool that checks code slides for JavaScript programs. In this attack, the attacker first got access to the account. Then it published a malicious version of the package, which was downloaded by over 4,000 users and aimed at stealing their credentials. Here's a snippet of the code introduced in the malicious update. First, the code imports the network API. Then, it downloads malicious code from an address controlled by the attacker. And finally, it evaluates or executes the malicious code that was downloaded. You cannot see the malicious code downloaded here, but it contains code that reads the NPM credentials in the file system and sends it over the network. The incident that I just described is not an isolated event. In November of 2018, an attacker was able to steal $13 million in bitcoins. And in 2019, another malicious update was downloaded 8 million times. The gist here is that these attacks are happening all the time and can cause a lot of damage. Let's understand why these attacks are so common. There are many reasons for that. First, applications have hundreds and thousands of dependencies, which increase their attack surface. Second, packages are updated frequently and often automatically, which makes them an easy target to exploit. Last, packages have unlimited access to powerful APIs that provide direct access to OS level functionalities, which creates a high potential for damage. In this work, we address this problem, the problem of overprivileged packages with unlimited access to security relevant resources. And to address it, we propose a permission system that enforces least privilege at the package level. This way, even if packages are in control of attackers, they will not be able to cause damage to applications or their users. Now, I'll give you an overview of the permission system design that we chose. The specifics about what packages are allowed or not to do are described in the paper, but I'll give you an intuition of what is possible. The policy states that packages should not be able to obtain references to security relevant resources by themselves. That is, the policy forbids imports of certain APIs and access to certain object properties. It is important to highlight that packages may receive references to security-relevant resources from other packages. It is the responsibility of developers to not share references to critical APIs to other packages. In the interest of time, I'm not going to talk about implementation, but all the details and link to the source code are in the paper. I'll be more than happy to discuss them with you. Now that I have given you an overview of the permission system design, I would like to highlight some trade-offs between alternative designs. Our proposed design incurs marginal performance overhead and is able to provide security at runtime by inspecting imports and member access expressions. An alternative design, based on restricting inter-module communication, provides opportunities for inspecting function calls as well as their arguments and return values. With this design, you can enforce a more fine-grained permission model and limit how APIs are used. This design, however, has some drawbacks. Performance is non-negligible and varies between 20 and 25%. And proposing a permission model that is flexible enough to accommodate callbacks, which are prevalent in JavaScript programs, is not a trivial task. Finally, we have a taint tracking design, which most people would consider to be ideal. This design allows developers to focus on what they really care about, which is the security of user information. This design, however, has strong drawbacks. Dynamic approaches have unacceptable performance overhead to be considered for practical adoption. and static approaches are too difficult to implement precisely in dynamic languages like JavaScript. Now I'll show you how we evaluated our permission system. We proposed 4 research questions, and the first one is concerned with how many packages can be protected with the permission system. To answer that, we report the relative amount of all packages in the npm repository that would need each permission. To answer the research question, we collected the latest versions of over 700,000 packages and performed the following activities. First, we analyzed both the manifest file and all JavaScript source code to identify declared dependencies, imports to other modules, and expressions with property access. Then, we infer permissions by searching for the parameter path to call to the required function. And last, we assign permissions to each package, recursively considering the permissions of its direct and indirect dependencies. The result of these activities is a dependency tree with permissions attached, like we show in this example. Permissions are composed bottom-up based on the permissions of package dependencies. The main result for this research question is that around 31% of all packages on npm do not need permissions. This translates directly to a reduced attack surface because these packages will not be able to cause damage to the application even if the accounts associated with them are compromised. In the paper, you can find more results for stratified samples of these packages based on different perceptions of importance. Moving forward to our second research questions, we analyze whether the permission system could contain attacks like the ESLint scope, event stream, and electronative notify attacks. To answer this research question, we replay all 3 attacks using our modified Node.js engine with the permission system. And the main result for this research question is that all 3 attacks are contained by the permission system. In the third research question, we are concerned about performance and transparency. We want to know what performance overhead would the permission system cause in Node.js applications, and if the permission system is transparent, that is, if it breaks existing programs. To answer this question, we measure and report the runtime overhead of the 20 most popular command line applications in Node.js when executing them with and without the permission system. The results indicate that the permission system incurs less than 1% of overhead, which we consider marginal. It also shows that the system is fully transparent, that is, it does not break existing programs if permissions are correctly set. Lastly, we investigate research question 4, which provides insights about review effort on package updates. In this research question, we want to know how much review effort could be saved on package updates with our permission system in a realistic setting. To answer this research question, we estimate review loads based on updates that request additional permissions. To do that, we analyze package updates over a 1-year period and observe how permissions change over time by replaying updates of dependencies for a sample of packages and applications. Here we show a graph with the permission changes for the 100 most dependent upon packages over a 1-year period. Here we can see that permission changes are rare. It is also important to highlight that around 33% of the updates are for packages with the all permission and would potentially have to be inspected manually. So the main results for these research questions are that permission changes in updates are generally rare, and that most maintainers would not face permission increasing updates more than once a year. Before I finish, I just want to recap what we talked about today. We discussed malicious package update attacks and why they're common in the Node.js NPM ecosystem. I presented the problem of overprivileged packages and proposed a permission system as a solution. The proposed system is simple, easy to adopt, and with marginal runtime overhead. If you enjoyed this work or have questions about it, please contact me. Thank you.
So, hello everybody and good evening from Stockholm. This is Davide Fucci from Blekinge Institute of Technology in Sweden. And we are currently in this session about security vulnerabilities in different domains. We have 3 papers from the technical track. First up, you just saw the presentation by Gabriel Ferreira and colleagues from CMU Pittsburgh, containing malicious package updates in NPM with a lightweight permission system. I wonder if there's already some questions from the audience for Gabriel. Okay, no question. Maybe I can warm up a little bit and ask a few. One is really more like a clarification question regarding your third resolution, where you actually check the validity of your approach. I wonder if the validation is something you did yourself or you involve some developers using the libraries, and which kind of libraries, how many of those did you use?
Right. So it was mostly, well, not mostly, entirely me. So research question, but all research questions, it was all me. Do you have specific questions about how I selected the packages?
Can you tell us a little bit how you select? How many packages were there?
Right. So for research question 3, we were trying to see whether the permission system would overhead or not, and whether it would cause transparency problems. Right. So if you include the permission system in the engine, would it break implementations? And in practice, we don't want the permission system to break implementations, right? But we know that implementing a permission system that is fully transparent is hard, right? That is one thing that we learned doing this work. So for selecting those things, we actually needed applications, right, to run the permission systems with. And finding application in Node.js, it's actually somewhat hard, right? I mean, there are some text editors and maybe web servers, and those all they're usually private, right? Applications that do that. So we actually selected command line applications to run these performance tests, right? Because we thought they would give some notion of user experience with the permission system, right? Assigning loads to those applications is, again, hard because you need to exercise the application, right? So I actually need to look at the code, see what they were doing, and try to get realistic loads for these applications.
So roughly how many did you go through?
So
Is
20
it in the order of
applications.
hundreds? 20.
Right.
Okay.
Well, so my initial pool of application was a lot larger, close to the hundreds, right? But some of them are harder to exercise. Some of them are harder to get review load for it, right? Especially if they require.
So I mean, load of easiness criteria, I guess, to select those.
Right.
I see. Okay, thank you. There's a question from Ivan Pashenko, who's asking, how can we integrate the approach into the existing pipeline of NPM?
Yeah, that's a great question. Well, so there are a lot of things that would have to be considered, and we discussed some of those in the paper, like integration with user-facing tools, right? So the NPM package manager itself would have to be changed. The implementation that we did required a little bit of change also into the Node.js engine, right? So there are a lot of small things that would have to happen so that these two could be integrated, right? From how developers state how the tools around NPM would work with the permissions, right? I would say it's not a trivial task, but it's possible. We have some ideas about what could be done. This is, of course, just a proof of concept, right? I mean, it's not a production ready piece of software, but we learned a lot along the way, and we can definitely help if people think it's a good idea. I was talking with David offline, and we have been talking, or we talked with Adam Baldwin, which is now an NPM and GitHub right now on the early stages of the project, and he had some ideas, and kind of connected us with the reality, right? So that we would create something that is actually practical. I don't know if that answers your question, but I'll be happy to talk more offline if you want to. Ivan.
Remember, there's after the Q&A, there's going to be a discussion where you can ask further questions and interact with the. So let's see if there's more questions from the audience. Maybe I can ask a short one. I was quite impressed by the result also of What do you think are the main so the fact that a few
permission updates, right?
Permission updates, yeah.
Right. So, and that's actually, now that you're talking, and I should have emphasized a little bit more, because so most of the attacks, malicious package updates, they usually increase permissions, right? So they attack very simple packages with no permissions, and then suddenly they require a lot more of permissions, right? By using eval, using metaprogramming constructs, or accessing the file system and the network API. So these attacks really kind of flag. They're easily flagged, right? Because they look very different from the permission changes that we see in normal updates. Right, so this is actually, I think it's an interesting result, right? So if you see that normally packages don't update permissions, I think that kind of gives us an opportunity to flag those updates more accurately, because they're significantly different from the ones that we normally see.
Right, so possibly application for SAST kind of scanner. Or some sort of heuristic based on updates.
Yeah, absolutely.
Interesting. More questions? Ivan, thanks you. So I guess that fully answer this question. A couple more minutes before we move to the discussion room, if you want, or the next presentation. So perhaps just one last question from my side. If you can tell a little bit on whether and how are you gonna attack the problem of transitive dependencies between packages, or if part of the current solution, or
the problem of what?
Transitive dependencies between packages.
Right. So so the permission system that we propose actually does that. Right. So we say that it's a compositional permission model, because a package has the permissions not only in terms of the code that it has, but also in terms of the dependencies that it has. And that's one thing that is usually hard to do, right? Because propagating information from dependencies is usually not done, right? It's tough, yeah. So there are drawbacks also and benefits of doing that. We might assign too many permissions to a package, even if that package is not actually doing all those things, right?
No.
But in terms of security, I think that is one desirable property, which is be on the safe side.
All right. Thank you so much, Gabriel.